With each passing day, we look back on where we've been and look forward to being part of something more tomorrow. From the moment our eyes open, material and technology solutions from Dow make our lives more comfortable, more convenient, more protected. Food stays safer, fresher, longer. And more after-use opportunities make flexible packaging a sustainable choice. From the store shelves to where it all begins, Dow materials promote growth, improve water conservation, and when it's time to package and ship, we're there to reduce damage and loss through enhanced film performance, along with one of the most comprehensive adhesives portfolios, all to ensure the products we need arrive where we need them most. Packaging designs are smarter. Non-recyclables become usable energy. Dow innovation can be found where you least expect it. It helps food taste better. Packages open and close with ease. But none of these breakthroughs happen in a vacuum. It takes collaboration to discover where innovation is hiding and accelerate it to market. So that we're not just keeping up, we're setting the pace. Driving a circular economy through responsible use and reuse of plastics, and committing to eliminate waste in the environment. Turning recycled plastics into school walls and desks, so more children can dream bigger, enabling the roads that connect us to last longer, and the power grids that light our way to be more reliable. E-commerce is growing, so packaged goods must be ready for the long, rough journeys ahead. Automobiles are lighter and more durable, and advancements in material science allow for a safe and elegant ride. We're living longer, staying active, craving comfort. From the products we rely on to the fields we run on, the amazing benefits of plastics are all around us. From generation to generation, Dow continues to deliver innovative solutions and unlock new opportunities for a better world. Everywhere, every day, together, we are working toward something more.
Hello, welcome. Good day, ladies and gentlemen. I'm your host, Jack. Could you please say yes or say hi to me right now if you can hear my voice loud and clear? Great, thank you. Thank you all. Okay, I am an editor from Ringer Trade Media, and I welcome you all to our exciting virtual conference today. The topic is Innovative Solutions to Polymer Modification and Recycling. Welcome to this webinar organized by Dow in partnership with Ringer Events. This is a part of the series of webinar Dow. Dow has organized to share with Asian business manufacturers about these initiatives to address both climate change and plastic waste through its innovative material solutions. Okay, today we will learn about these topics. Let's go to the agenda today. We will learn these several topics about we'll have introduction now, and later we'll be having the presentation by Mr. Muthu Subramanian, the Senior Development Specialist, and also presentation by Ms. Lo Bitin, Senior Development Specialist too, and we will later have an open forum Q&A and then the closing. Okay, so let's talk about what we will learn today. You can see, first of all, we will learn how Dow can improve the polymer modification process and enhance recycling with case studies of actual applications. And two, how the performance of engineering plastics can be further improved. And third, how manufacturers can maximize their use of high-value recycled plastics, and the effective process to modify hot materials such as nylon, polyester, PC, and PVC. Okay? And as I said a while ago, we will be having an open forum. And also, you are welcome to ask your questions in the chat room area. Your questions may be answered in the chat room by those staff or by our assistants, or the speakers will answer them in person after their presentation in the Q&A forum, or contact you after this webinar. So let's move on. Let's talk about our speakers today. Our first speaker presenter today is Mr. Muthu Subramanian. As I said, he is a senior development specialist of DAL. And Mr. Muthu Subramanian is the senior of the development specialist for DAL. DAL's infrastructure, customer and transportation business, and responsible for the technical service and development for Singapore, Malaysia, Vietnam, and the Philippines. He has been working with DAL for 18 years and engaged in the elastomers and rubbers field for 32 years and has 3 granted patents. Muthu holds a Master of Degree in Polymer Chemistry from the University of Madras, India. And later, we will also have the presentation from Ms. Dol Lo Bitin. Ms. Lo Bitin has been with DAL for more than 20 years, including an initial 5 years at DuPont DAL Elastomers. She is currently the Senior Development Specialist for DAL, just like Mr. Muthu, Infrastructure, Consumer and Transportation Business, and responsible for Indonesia, Thailand, Australia, and New Zealand. Bitin has a Master of Science in Polymer Technology from Loughborough University, England, and MBA from Strathclyde Graduate Business School, Glasgow, United Kingdom. So let's looking forward to their presentations later.
Good afternoon and welcome everyone. Thank you for taking your time out of your busy schedule today to attend this webinar. My name is Muthu and I am joined today by my colleague Bitin. Both of us are Senior Development Specialists for Dow Infrastructure, Consumer and Transportation Business. Let's look at the innovative solutions offered by Dow for polymer modification and recycling. This presentation consists of 4 topics. I will cover the first 2 topics, that is, Dow offerings for nylon modification and Dow offerings for polyesters and PC modifications. Bitin will cover alveoli tech polymers for high demanding PVC modification and Dow modifiers for recycling. Dow develops premier material science solutions that are essential to human progress. We deliver a broad range of differentiated technology-based products for a wide range of industries. The following slides will highlight our innovative polymer modifiers for compounders. Why do we need modifiers? Since the processing and or properties of one polymer alone are not sufficient to respond to the requirements of the end-use application, we add a modifier that synergistically enhances the properties of the product. Synergy is defined as the interaction of 2 or more substances or other agents to produce a combined effect greater than the sum of their separate effects. Dow modifiers are used for the modification of polymer systems such as polyamide, polyesters, PVC, polyolefins, ABS, PC and its blends, and PLA. The appropriate modifier could be selected based on the polymer system and modifier function. We have both polar and non-polar modifiers. First, let's look at polar modifiers. Fusabond is anhydride modified polymer and used as impact modifier and compatibilizer for polyamide and coupling agent for polyamide, polyolefins and wood plastics composites. It is also used as compatibilizer for polyolefins. Surlyn is ionomer and used as impact modifier for polyamide. Retain is anhydride modified polyolefin used as compatibilizer for polyamide. Alveoli is ethylene terpolymer used as impact modifier, compatibilizer and coupling agent for polyesters. It is also used as impact modifier for rigid PVC, PC, PC PBT blend and permanent plasticizer for flexible PVC. It is also used as impact modifier and processing aid for PLA and modifier for asphalt. Alveoli AC is copolymer of ethylene and acrylate used as impact modifier, compatibilizer and coupling agent for polyesters and impact modifier for polyolefins, ABS, PC and PC ABS blend. It is also used as processing aid for polyesters, ABS and PC blends and master batch carrier resin for nylon, polyesters, PVC, polyolefins, ABS and PC blends. Entira is used for imparting anti-static property in polyolefins and polystyrene. For the non-polar modifiers, we have Nordal EPDM rubber. Affinity and Engage is ethylene-based elastomers and Versify is propylene-based elastomers. Infuse is ethylene-based block copolymer and Intune is propylene-based block copolymer. These products are used as impact modifier and compatibilizer for polyolefins. Non-polar polymers provide better performance for polyolefins. If polarity and chemical resistance are required, polar modifiers can be used. Moving on to Dow offerings for nylon modification. Fusabond is a functional polymer having anhydride functionality. Without malic anhydride functionality, polyolefin is not compatible with polyamide. Malic anhydride functionality can react with amine functional group in polyamide and compatibilize the blend. After malblending Fusabond and polyamide, Fusabond particle size could be typically 200 to 300 nanometer. Fusabond offer excellent toughness performance for both PA6 and PA66. We had a product called Amplify GR216, which is now renamed as Fusabond N216. Fusabond N216, N493 and N525 are malic anhydride grafted polyolefin elastomers. Fusabond N416 is malic anhydride grafted EPDM. Fusabond N493 has medium. N416, N216 and N425 have high malic anhydride levels. Fusabond N493 is universal modifier for PA6 and PA66. We have full range of toughener for polyamides, general to super tough. Room temperature notched izod will be less than 200 joules per meter for general, 200 to 800 joules per meter for medium, and more than 800 joules per meter for super tough. The chart shows 0 and 23 degrees centigrade toughness increases with increasing level of Fusabond N493 in PA6 compound. Polyamide modification could be done for various applications, including sporting goods. Fusabond N416 is premium modifier for toughening PA66. Fusabond N416 offers excellent low temperature toughening performance. By varying the level of Fusabond N416, the full range of toughness, that is, from general purpose to super toughness, can be achieved in PA66. The chart shows super toughness performance at low temperature as well as room temperature can be achieved at around 28% level of Fusabond N416. Since maleic anhydride level is high for Fusabond N416, it is not suitable for PA6. Fusabond N216 offers general purpose to super toughness for both nylon 6 and nylon 66. The chart shows room temperature impact and flexural modulus data for PA6 compound. As expected, the impact increases and modulus decreases with increasing level of Fusabond N216. We have seen similar trends with PA66 blends as well. By varying the level of Fusabond N216, general purpose to super toughness can be achieved in PA6 and PA66 compounds. Fusabond N216 has better cost performance balance. Fusabond N216 can be used in various applications. Some of the applications are transportation, consumer, hardware and furniture parts, industrial machinery parts, electrical connectors and switches. Fusabond A560 offers high affinity to glass and mineral fillers. With a low concentration of 3.5 to 7%, it increases the notched izod impact strength of the glass reinforced nylon up to 30% and 50% respectively. The chart at bottom right shows apparent viscosity versus shear rate of PA6 compound with 33% glass fiber and 10.5% modifier comparing control Fusabond N493 and A560. Fusabond A560 is identified as 672-91A in this chart. We can see that Fusabond A560 is showing lower viscosity at high shear rate. Hence, Fusabond A560 reduces compound melt viscosity and provides better flowability for mold filling and better surface appearance. A560 is chemically modified ethylene acrylate copolymer and not grafted. Hence, it will not increase melt viscosity during processing. Grafted maleic anhydride has higher reactivity. Hence, maleic anhydride grafted polymer will increase viscosity. The chart at upper right shows gloss of modified nylon 6 comparing 5 and 10% Fusabond N493 and 10% Fusabond A560. We can see that Fusabond A560 showing higher gloss at 20 and 60 degrees. Terpolymer does not go through reactive extrusion, hence yellowness index is lower. Better gloss shown by Fusabond A560 is due to good flow and lower yellowness index. Fusabond A560 shows higher mechanical properties retention compared to maleic anhydride grafted polyolefin elastomers in glass fiber reinforced nylon 6 and nylon 66. The application for glass fiber reinforced nylon is mainly in auto parts. Surlyn is chemically known as an ionomer resin. They are ethylene and acid copolymers that are partially neutralized with a metal salt. The metal salts are typically sodium or zinc. The acid metal linkages act like crosslinks, imparting outstanding solid state properties. The crosslinks are thermally reversible, allowing the polymer to be melt processed. The schematic structure and chemistry of Surlyn is shown on the right. Three features, that is polyethylene crystallinity, amorphous region, and ionic clusters, determine the microstructure and properties of Surlyn. The unique attributes of Surlyn are excellent melt strength, excellent transparency, excellent chemical resistance, and high scratch and abrasion resistance, higher stiffness compared with other ethylene copolymers. Surlyn is another offering for nylon modification and provides general to super toughness. The value propositions for Surlyn are high melting point and modulus and easy handling compared to maleic anhydride grafted polyolefin elastomers. Surlyn has FDA compliance for foot contact. Surlyn is highly compatible with nylon. It is possible to make nylon Surlyn alloy. This is called alloy since dosage of Surlyn is higher and the dosage could be more than 20 to 50%. Nylon Surlyn alloy can be used for mold-in color application, which means no need painting. Mold-in color is preferred since scratching will remove the paint. For mold-in color, pigment is added in the compound. Mold-in color application need high gloss and high scratch resistance materials. This alloy has a very high gloss because of excellent compatibility. The very high gloss provided by this alloy can be seen in the plaque pictures. Scratch resistance of various materials are shown in the table. We can see that PMMA has the best scratch resistance in this comparison, but impact and chemical resistance are not good for PMMA. Surlyn and Surlyn nylon alloy are showing better scratch resistance than PC, ABS, PC ABS blend, POM, nylon 6 and nylon 12. The application for this include electronic appliance. Electronic appliance use PC ABS, but scratch resistance is compatible with nylon. It is possible to make nylon Surlyn alloy. This is called alloy since dosage of Surlyn is higher and the dosage could be more than 20 to 50%. Nylon Surlyn alloy can be used for mold-in color application, which means no need painting. Mold-in color is preferred since scratching will remove the paint. For mold-in color, pigment is added in the compound. Mold-in color application need high gloss and high scratch resistance materials. This alloy has a very high gloss because of excellent compatibility. The very high gloss provided by this alloy can be seen in the plaque pictures. Scratch resistance of various materials are shown in the table. We can see that PMMA has the best scratch resistance in this comparison, but impact and chemical resistance are not good for PMMA. Surlyn and Surlyn nylon alloy are showing better scratch resistance than PC, ABS, PC ABS blend, POM, nylon 6 and nylon 12. The application for this include electronic appliance. Electronic appliance use PC ABS, but scratch resistance is not good for this blend. Usually this is painted with UV coating, which is costly and contains solvent, hence it is not environmental friendly. The unique properties of Surlyn nylon alloy are excellent appearance, color brilliance, high gloss, high scratch and abrasion resistance, exceptional toughness and durability, excellent weatherability with stabilizer package, excellent chemical resistance and low specific gravity. The golf cart exterior part is one of the commercialized application for this alloy. Moving on to Dow offerings for polyesters and polycarbonate modifications. Alloy AC is copolymer of ethylene and various acrylate monomers. We have copolymers of ethylene and methyl acrylate, which is EMA, ethylene and ethyl acrylate, EEA, and ethylene and butyl acrylate, EBA. Alloy PTW is ethylene, N-butyl acrylate, glycidyl methacrylate terpolymer. Glycidyl methacrylate has reactive epoxy functionality. Alloy AC and alloy PTW are the toughness and hydrolysis stabilizers for polyesters. With alloy PTW, we can reach super toughness, but viscosity is increased. Alloy AC leads to acceptable toughness at low addition levels and provides the added benefit of enhanced flow. A combination of both leads to high toughness at moderate flow penalty compared to the unmodified compounds. The chart shows 0 and 23 degrees centigrade toughness increases with increasing level of alloy PTW in PBT compound, and super toughness performance can be achieved at more than 28% level of alloy PTW. The table shows the modifier selection guide for PET, PBT, and glass fiber reinforced compounds. The appropriate modifier could be selected based on modifier function such as level of toughness, compatibilization, and flow. PET need nucleating agent, but PBT do not need. Surlyn 8920 is used as nucleating agent for PET and the dosage is 1 to 2%. Surlyn 8920 alloy PTW blend can be used for PET. However, the addition sequence should be adding Surlyn first and then PTW, since alloy PTW reacts with both Surlyn and PET. This will increase temperature resistance and toughness. Surlyn 8920 alloy AC blend can also be used for PET. The application for polyester modifications include electrical connectors and components. Alloy PTW is ethylene N-butyl acrylate glycidyl methacrylate terpolymer. The N-butyl acrylate section acts as a soft polymer with a low glass transition temperature which provides the rubber toughening effect. The glycidyl methacrylate functional group reacts with the polyester matrix to improve the modifier dispersion and the bonding to the matrix. It also has good affinity to glass. The chemical structure of this product makes it a highly effective toughener for not only PBT neat resin but also for the glass fiber reinforced PBT. The chart shows the impact strength of 15% glass fiber reinforced PBT with 4 of our modifiers at 5 to 15% level. The alloy PTW shows the highest impact in this comparison. Alloy PTW increases melt viscosity, which is not good for injection molding process. Hence, we cannot add high amount of alloy PTW. Typically, 3 to 5% alloy PTW is enough since glass fiber system do not need high toughness. To improve melt flow, alloy AC can be used instead of alloy PTW. High N-butyl acrylate or methyl acrylate content alloy AC grades can be effective at low concentration of 5% to moderately improve toughness of the glass-filled PBT. Alloy AC 34035 is particularly good in achieving a higher heat deformation temperature. The modifier effectiveness trend in glass fiber PBT system is similar to that of neat PBT system. Fusabond A560 can also be used for PET glass-filled system since this is acrylate-based copolymer. PC is good engineering plastics and has good toughness above 0 degrees centigrade, but below minus 10 degrees centigrade impact is poor. The top right chart shows the toughening of PC with alloy AC versus MBS and ABS modifiers. We can see that alloy AC and alloy AC PTW blend shows better impact at 0 and minus 30 degrees centigrade than PC control and comparable to MBS and ABS. The bottom right chart shows the melt viscosity of modified PC. We can see that PC melt viscosity is high, hence it is not easy to use it for thin wall application. MBS and acrylic modifiers are not able to lower the melt viscosity, whereas alloy AC and alloy AC PTW blend shows lower viscosity than control and MBS and acrylic modifiers. Hence, alloy AC and alloy AC PTW blend shows better processability and enables processing at faster speeds. They can be used as a toughening resin and processing aid for PC and PC alloys. Alloy AC and PTW are in pellet form, but MBS and acrylic are powder form. Hence, alloy AC and PTW are easy to handle. I would now like to hand over to my colleague Bitin to share about our modifiers for high demanding PVC modification and plastics recycling. Bitin.
Good afternoon and thanks you for attending today's webinar. Today I would like to share with you Dow alloy polymer for high demanding PVC modification and also Dow polymer modifier that can be used in plastic recycling. For a long time, PVC is considered a low-end product with poor properties and not environment friendly. But with improvement in additive technology such as plasticizer, PVC's quality and performance has significantly improved, and Dow alloy polymer is one of the modifiers that can be used to improve PVC performance for more demanding applications. Alloy ethylene polymer has a different chemistry from alloy AC acrylic copolymer presented in previous slide by Muthu. Alloy polymer is either an ethylene vinyl acetate carbon monoxide copolymer or an ethylene N-butyl acrylic carbon monoxide copolymer. The presence of carbon monoxide monomer increases polarity of alloy polymer and result in excellent compatibility with PVC and other ingredients in the formulation. Alloy polymer has low glass transition temperature of minus 60 degrees, hence it improves low temperature flexibility of PVC. PVC has molecular weight of between 50,000 to 150,000 and alloy has a molecular weight of between 250,000 to 400,000. Hence, alloy polymer gives higher tensile strength and low and higher tear resistance to the vinyl compound when it is used as a modifier to PVC. Unlike liquid plasticizer, alloy will not migrate to the surface of PVC due to its high molecular weight. Hence, it prevents brittle failure and improves long-term performance of flexible PVC sheet of component or parts. Alloy polymer also provide better compatibility between filler and polymer matrix, resulting in better surface appearance in rigid PVC. It also gives better filler dispersion and enable higher filler loading as compared to acrylic impact modifier used in rigid PVC. Lastly, alloy polymer is phthalate free since it is considered environment friendly. Alloy polymer is used as a modifier for both flexible and rigid PVC. In flexible PVC, alloy polymer can be used as a non-migrative polymetic plasticizer. It enhances the long-term flexibility performance of PVC to make long-lasting products for more demanding applications. In rigid PVC, alloy polymer can be used as an impact modifier and also act as a processing aid for rigid PVC compound. Industrial flexible membrane applications such as pump liner, single-ply roofing, and industrial films are just a handful of demanding applications where long-term reliability is critical. Alloy polymer has been used in many sheet and film goods since 1975. This proves that alloy polymer enable long service life for this application. Most injectable products use liquid plasticizers, which results in short shelf life because of plasticizing migrating out. Compared with liquid plasticizer, alloy polymer is non-migrating since it actually has longer shelf life. It also maintains low temperature flexibility even in extreme cold weather. In wire and cable application, alloy polymer has excellent flexibility retention in both hot and low temperature and good oil resistance for critical environments like automotive. It also acts as a coupling agent for high filler loading formulation. For hose and flexible tubing, alloy polymer is used where improved resistance to extraction is required, along with flexible durability. PVC thermoform sheet has been used for automotive interior parts such as dashboard skin, door trim skins, and car seats because of its enhanced design freedom with superior grain retention. But it has more volatile and foggy issue. Adding alloy polymers helps to reduce volatile and foggy issue with PVC part. It also provides long-lasting cold temperature flexibility performance. For liner use to repair oil sewage pipes, semi-rigid PVC pipes liner modified with alloy polymer provide unique thermoforming capability, enable ease of repairing old pipes, and cause less traffic issue in big city while repairing. In construction profile application, alloy polymer is used to improve impact resistance and at the same time have high gross surface and good weathability. Now I would like to share with you a range of Dow products for recycling application. Plastics has been invented for more than 100 years. In the late 1950s and early 1960s, improvements in manufacturing process brought the cost of making plastic down dramatically, paving the way for cheap mass production. Many things that we take for granted today depend on it. For example, plastic packaging has allowed supermarkets to offer a wide range of fresher produce in a variety of portion size. Thus, plastic gives us a lot of convenience. However, plastic waste can cause harm to humans, animals, and plants through toxic pollutants. It can take a long time for plastics to break down, so the environment damage is long-lasting. Recycling is become one of the most important actions currently available to reduce this impact and as it provides opportunity to reduce oil usage, carbon monoxide emission, and landfilling. One major challenge from producing recycled resin from plastic waste is plastic degrade during reprocessing and subsequent use, which result in reduction in mechanical property of recycled resin. Another major challenge in plastic recycling is polymer cross-contamination, as different types of plastics are often combined in manufacturing process. This makes recycle much more difficult because different plastic types are not compatible with each other. Because of the inherent immiscibility at molecular level and differences in processing requirement at micro scale. Our proposed solution is to improve poor properties of recycled plastic caused by lack of compatibility between most polymer is to add compatibilizer to strengthen the weak interface between dispersed particle and continuous phase. Left-hand side figure shows the dispersion of two incompatible polymers without compatibilizer, and there is a clear interface between the dispersed particle and the continuous phase. Hence, the crack propagation would be expected to follow preferably at the weak interface between the two polymers. The right-hand side figure shows the dispersion of two incompatible polymers with compatibilizer. The compatibilizer improves the compatibility between the two polymers by strengthening the weak interface between the dispersed and the continuous phase. Hence, it improves the mechanical property such as elongation, impact strength, and flex modulus. This slide shows Dow selection guide for different types of recycled stream. Dow offers include compatibilizer, impact modifier, and coupling agents to improve performance of recycled plastic. For example, for PET with minor fraction of PE, you can use alloy ethylene polymer or fusable functional polymers as compatibilizers to improve the performance of recycled plastics. For PS with minor contamination of either PE or PP or ABS, you can use alloy AC copolymer as compatibilizers to improve the performance of the recycled plastics. Mixed recycled materials are usually more difficult to recycle. As I showed you in previous slides, Dow offers a wide range of compatibilizers for different waste composition. This slide shows the product grade offering for each type of waste composition. In the next few slides, I will show you example of Dow modifier being used in recycled plastics. This slide shows example of using fusable functional polymers for polyethylene recycled stream. Multi-layer films are common in packaging application and usually consist of two or more polymers such as PA PA or EVOH and PE EVOH PA. And most of these films are co-extrusion film. Fusible compatibilizer can effectively reduce the gel and haze and also improve the mechanical performance such as tear and tensile of the film. Hence, fusibles enable the multi-layer films to be used back in film application. At the same time, fusible M603 also enable multi-layer films to be used for injection molding application. As shown in the center graph, 0.5 weight% of fusible M603 give better notch iso impact strength than 1 weight% of traditional grafted compatibilizer in HDPE EVOH blends. It is common for recycled streams to contain some moisture. Bottom graph shows that fusible M603 also can effectively improve the notch iso impact strength in moisture containing recycled stream versus traditional grafted compatibilizer. Wood plastic composite is compound consisting of a basic resin, typically PE, PP or PVC, reinforced with wood flour. In HDPE or PP wood composite, recycled HDPE or PP is commonly used. Fusable coupling agent can be used to improve the interfacial compatibility between recycled HDPE or PP with wood flank. When compared to traditional grafted coupling agents, Fusable M603 functional polymer further improves the stiffness, flex strength, and reduce water absorption of wood plastic composite. As shown in the left bottom graph, 3% of M603 in wood PE composite shows significantly lower moisture absorption than traditional grafted coupling agent. Hence, Fusable M603 helps to increase moisture resistance in wood PE composite at significant lower usage level than traditional grafted coupling agent. M603 also has higher flex strength than other traditional grafted, as shown in right bottom graph. Commercial carpet tile is generally comprised of a fiber-wearing layer, usually made of nylon or PP, a non-woven polyester material which is in turn bonded with a secondary backing. This secondary backing can be PVC, bitumen, or polyolefin. To recycle carpet tile, the pulp fiber required to be mechanically separate from the packing. Hence, significant capital investment is required. The materials resulting from the recovery process can also reduce the standard of the new carpet component. Dow's solution on recyclable carpet tile is to use polyolefin elastomers carpet tile backing developed by Dow that can be easily be recycled as compared to bitumen and PVC backing. Fusable functional product is used as a compatibilizer to improve the compatibility between different materials, which makes it possible to recycle the whole carpet tile structure without layer separation. Majority of plastic pellets are made from HDPE and PP or recycled HDPE or PP. Both specialty elastomers products such as engaged polyolefin elastomers and versified elastomers can be used to improve the mechanical property of recycled containing HDPE or PP pellets. Dow modifiers is used to improve tensile, elongation, impact resistance, and low temperature impact resistance of the pellet. Below figure shows the morphology of PP and LDPE blend with and without into propylene olefin block copolymer as compatibilizer. You can see that the dispersion of PE and PP improves significantly with addition of into OBC. Hence, Dow modifier can improve the compatibility between PE and PP and support the use of PE-PP matrix recycle stream. Dow offers a broad product portfolio as a polymer modifier for polymer systems such as polyamide, polyester, PVC, PP, PE, ABS, PC and its blend, and PLA to help compounders create plastics that work harder or meet special requirements. Depending on the polymer system and the polymer modifier function and or process used, Dow has a specific product to meet each requirement. Today, my colleague Muthu has shared with you the various grades of fusable that can be used to improve toughness of polyamide 6 and 6,6, depending on the level of toughness required. He also shared the benefit of using alloy PTW polymer and alloy AC acrylic copolymers to enhance PBT and PET resin to improve impact strength, melt flow, and hydrolysis resistance. Alloy PTW polymer and alloy AC acrylic copolymer can also use to improve toughness and processability of PC and PC alloy. For PVC, Dow offers alloyed polymer as a modifier for both flexible and rigid PVC. Alloyed polymer is used as an impact modifier and also acts as a processing aid for rigid PVC compound. However, in flexible PVC system, alloyed polymer is used as a non-migrative polymeristic plasticizer. It enhances long-term flexibility performance of PVC to make long-lasting products for more demanding applications. For PP mixture recycle stream, you can use engaged polyolefin elastomers, versified elastomers, and infill propylene olefin block copolymer as modifier to improve the toughness, tensile, elongation, and low temperature performance of PE-PP blend. One major challenge in plastics recycling is polymer cross-contamination, as different types of plastics are often combined in manufacturing process. Today, I have shown you that fusel-bond compatibilizer can be used to improve the mechanical performance, such as tear and tensile of recycled stream from packaging film containing PE, PA, and EVOH. At the same time, fusel-bond M603 enable multi-layer film to be used for injection molding application with better not-iso impact strength than traditional grafted compatibilizer in HDPE EVOH blend. Another function of Dow monomer modifier is used as coupling agent to provide a chemical hook in a few polymer system, and it enhances the adhesion between filler material and the polymer matrix. As I shared in my previous slide, fusel-bond M603 functional polymer helps to improve stiffness, flex strength, and reduce water absorption of wood plastic composite when compared to traditional grafted coupling agent. Thank you very much for your attention.
This is Jack, and I'd like to thank you for both speaker, Mr. Muthu Subramanian and Ms. Lo Bitin, for the interesting presentations. Okay, we will have a sharing of ideas through our open forum. But before that, I would like to have some hi or yes if you can hear my voice. Please leave a hi or yes in the yes. Thank you. So I'm very happy for that. Thank you. And now I would like to invite our speakers to do our open forum Q&A time. I see there are some questions from our audience. Also, we have collected some great questions during our registration because we asked for our attendees to fill in some questions, some open questions in our registration form, right? I would like to post them and invite our speakers to answer them one by one. We select some very great questions. So let me now introduce you our first speaker, Mr. Muthu Subramanian. Mr. Muthu,
Yes, Jack, I'm here.
hello, great presentation. There are several great questions asked in the chat room also. But let's move to our to the questions we selected from our registration form. Okay.
Okay, Jack, thank you.
Okay, you have the floor now. Please answer those questions to us.
Okay. So the first question I see here is, can ethylene acrylate copolymer contain more than 30% acrylate? If possible, is there any problem with the production process? Okay, this one, yes, we do have grades having more than 30% acrylate content, but we need to know the requirements and the process, and also what is the intended application for this, in order to determine whether the grade with 30% acrylate content is the appropriate grade, or do we need to go for any other grade, and also to address any if there is any potential issue with the production process. Okay, let me move to the second one. what are the options available for rubber machinery in the field of blending polymer with plastic material, especially for calendering process, and the sheets will be able to recycle. It depends on what type of plastic material is blended with rubber. Like normally for blending rubber with LDPE or LLDPE, conventional rubber internal mixers can be used. And for blending with HDPE or PP, we need to have a heating capability in the internal mixer because the melting point of HDPE and PP are higher. And if you are talking about blending with engineering plastics, then definitely we need to have a twin screw extruded because engineering plastics have even a higher melting point. And the sheets will be able to recycle. Yes, I think you are talking about recycling in process waste. So this one you can, mix it in the internal mixer, or but for using a twin screw, then probably you may need to grind it to the smaller particle. Then only you will be able to mix it. And the third question is, what is the concern in polymer modification? So in this presentation, we have shown the data and discussed about our modifiers, how it is compatibilizing and act as a coupling agent with the mineral fillers to improve the impact, as well as the processability of engineering plastics. And for high heat resistance engineering plastics, for example, PPS, there is a concern whether adding modifier will cause a reduction in the heat resistance performance. So for PPS, we can add a blend of modifier, like we can add our Surlyn and GMA containing polymer, TEP polymer, which is our alveoli PTW. Since this blend will react with the PPS, and it can increase the heat resistance because it can cross-link with the PPS. Because of that, it can improve the heat resistance as well as the toughness. And the other concern is in polymer modification, whether the modifier will affect the clarity of the final product. And if clarity is very critical, then we may need to limit the dosage of the modifier. Okay, fourth question is, any method can be used to determine the ratio of the polymers in an alloy sample. Okay, for this, FTIR can be used to identify the chemical composition of the polymers in the alloy, and also need to create a calibration curve by plotting the peak height or peak area for the known different ratios of those polymer blends. And after that, using the calibration curve, it might be possible to determine the ratio of the polymers in the unknown alloy sample. And the last question is, can you talk about comparison with core shell type of impact modifier like MBS, and I think next one is acrylic? Yes, this one I have covered in the PC modification topic. I have shown the charts using comparing alveoli versus MBS and acrylic modifiers for the toughening and processability of PC. And alveoli shows, in terms of impact, alveoli is very similar or better performance compared to the MBS and acrylic. And furthermore, alveoli has additional benefits such as better processability and enable processing at faster speed. This trend also we observed in the modification of ABS. So for modifying ABS, similarly, alveoli can improve the impact compared to the MBS and acrylic. And also, alveoli will be able to reduce the melt viscosity and increase the flow of ABS. And another advantage of alveoli is in pellet form. So easy handling, whereas MBS and acrylic are in powder form. Okay, Jack. Yeah.
I think that's great for answering for this 5, and I think that some of the answer also answered the questions asked in the chat room already. But before that, before we move on later, let's welcome Low Beating to answer several questions we collected during the registration. Okay, is Beating there?
Yes.
Oh, great,
Good
Beating.
afternoon.
So now we prepare the 5 questions we collected from registration. I would like to invite you to answer them one by one, okay, to our attendees.
Okay, first of all, I'd like to thank everyone for joining and thank you for the question. Okay, the first question, what is the function as a compatibilizer? As I explained in my slide, a function of a compatibilizer is to improve the compatibility between two immiscible polymer by strengthening the weak interface between the disperse, and the continuous phase. Hence, it actually helps to improve the mechanical properties such as elongation, impact, and flex modulus of the incompatible polymer blend. As just now I mentioned in my example, if you have a blend of HDP and EVOH, by adding a compatibilizer like M603, it actually helps to improve the notch impact strength significantly as compared to you do not add it. Okay, question 2. How to utilize multi-material laminate waste for upcycling? Okay, for multi-layer laminate waste, you can actually add a compatibilizer to, like, for example, to improve the mechanical property of the recycled resin. Compatibilizer also helps to reduce the gel and the haze for the flume. But if you are considered to use for packaging, I would say that it's more on not to upcycle them. It's more a downcycle. Like you have to use it for like for example a trash bag, because once you even you put a compatibilizer, the compatibilizer amount is actually very low. It's like 0.5 to 3%, not more very low. So it will not give you the improvement that you want. However, you may want to look into like going into different like molding application, like which you may upcycle depending on what type of injector part you are looking into, and what is your this recycle waste, because recycle waste is very wide. Question 3, how modifier control consistency property of recycled plastics? Modifier does not control the consistent property of recycled waste. As the consistency property of the recycled waste actually depend on source of the waste, the treatment of the waste, how you treat the waste, and the process condition, how you compound it. So this will actually impact on the consistency of the recycled waste. What down modifier do is actually improve the performance of the recycle waste. Like you either add a compatibilizer for two immiscible polymer, or you add a impact modifier on recycled PP or PE to improve the impact strength, so that you can use in certain application for injector parts. Fourth question, does Everloy has FDA grade? Everloy has a lot of grades, and a few of this grade is FDA approved. For example, HP661, it actually can use for direct food contact. But we will prefer that if you have this sort of requirement, let us know what is your performance and process use, and we can recommend you a suitable one. Next part of the question is, do we still need to add liquid plasticizer once we use Everloy polymer as plasticizer? Everloy polymer is a non-migrative polymeric plasticizer, and it actually can use to replace liquid plasticizer, as I mentioned in my slide, but it is higher cost than liquid plasticizer. So we actually recommend customer to do use a combination of alloy, the polymer, and liquid plasticizer, so as to allow you to meet your performance requirement at the same time to be cost effective. Okay, for example, if your existing formulation have liquid plasticizer, have DOP, you can actually try to use like alloy 741, about 1.5 parts of 741 to replace 10 parts of your liquid plasticizer like DOP. So you may try to put 10 or 15 parts of alloy with a combination, depending on what type of requirement, what is your target you're trying to achieve. So you just to ensure that you have meet performance at the same time cost effective. Okay, last question. What are the benefits of using alloy as compared to acrylic-based impact modifier for rigid PVCs? Okay, the three main benefits of using alloy as an impact modifier for rigid PVC as compared to acrylic-based include alloy actually able to maintain ductile impact performance even at higher feeder loading. We have seen that this actually provide opportunity for cost reduction. For example, at 4% of alloy 4924, it actually give you a ductile failure mode, whereas acrylic impact modifier give you a brittle failure at 20 parts of filler. The second benefit for alloy as an impact modifier, it actually give you a better finish and smoother surface. This is because alloy provide a better compatibility between the filler and the polymer matrix. The third one is actually, alloy also act as a processing aid. We have seen that it actually enable you to reduce the processing temperature of up to 20 degrees. So you can actually process at 160. With this lower extrusion temperature, it actually allows you to reduce the heat stabilizer content in your PVC compound, which in turn reduce the overall system cost. That's end my 5 questions. Okay, Jack.
Great questions and answer for beating. Now, I see there's really several questions to left for Mr. Mutu to answer, and also I would like to, if we still have time, to answer 1 to 2 questions, I guess, in the chat room. Okay, Mr. Mutu.
Okay, Jack.
So I leave these 2 questions for you. I'll come back later.
Okay, sure. Thank you everyone for the very good questions again. So the first one here is, does Dow have modifier to improve toughness of biodegradable plastics such as PLA? Yes, we do have a modifier for PLA. Our alloy PTW can improve the toughness of PLA. But if PLA is used for food contact application, then alloy PTW is not recommended. We have another product called Biomax SG120. So this one can be used as an impact modifier for PLA for food contact application. And the modifier level could be between 2 to 5% depending on the requirements. If let's say the final product require high transparency or clarity, then we suggest the additional level of 2%. But if the toughness requirement is quite high and if it is low transparency is acceptable, then we can add 5% of the modifier. And I would like to highlight here that alloy PTW and Biomax SG120 are not biodegradable. Then the second question here is, Dow has introduced a modifier that does not require painting, mold in color. Can this modifier be used for PP? Okay, the modifier which we were talking about here is the Surlyn used to modify polyamide or nylon. Surlyn is an ionomer and has excellent compatibility with polyamide, and it also has high scratch resistance. Hence, it can be used in applications that require a higher glossy appearance, final product, and also does not need painting. We have successful case with using Surlyn to modify HDPE to improve the scratch resistance. But for PP, you can also try the same concept to improve the scratch resistance, but the issue is PP has poor compatibility with Surlyn. So we need to use a compatibilizer such as a malic anhydride grafted PP to improve the compatibility between PP and the Surlyn. This may enable a better scratch resistance, but whether it will have a better, higher glossy appearance and then mold in color, this is something we still need to validate. Okay, Jack, back to you.
Riemannian, hello. Great answer for that. And I would like to ask you, do you see there's really many questions asked in the chat room?
Yes, I see some of the questions here.
Yeah, so I think your presentation is really great, interesting, and provokes there were insightful ideas that because of the time issue, I understand, but I would like to publish at least one question so far for you to answer, maybe.
Oh, okay, Jack. Yeah.
I would like to maybe try this one, okay? Which is asked by Avinalish Rathod. How this question you read and answer, please.
Okay. How Fusabond A560 helps to enhance the bonding between PA6 and glass fiber. Okay. Fusabond A560 has a functionality very similar to the malic anhydride. So that's why it can be used as a coupling agent. Also, it functions as a coupling agent for glass fiber reinforced PA6 because of the functionality, which is very similar to the malic anhydride in terms of the chemistry.
I'd like to say goodbye to Mr. Mutu and Sabrimania and also Ms. Lobit. For the last information page is that I would like to welcome everybody to visit their website, and also you can see the emails from our speakers today. You are also welcome to email them. Thank you all for our participants who joined us today